So to everyone that's listening us, so GM or good evening, wherever you are. Welcome to the second lesson of Basic Maths Behind ZKs course. So my name is Milica, also known as Xerox Milica through Twitter and other social accounts. And last time we spoke about what makes ZK a ZK. And this time, we'll speak about modulus and modular arithmetics. So let's see if I can share my screen. And my, so I might need a permission. Do I have permission? Yeah. I don't know, guys, can you see my screen?
Yes, we can see it very, very clearly.
All right. So, welcome, everyone. And modulus is something we usually use throughout the daily basis. But we're not always quite aware of it. So usually every time we take a look at our watch, our hand watch, and if we're using a mechanical one, and basically that's something that older people, when we are telling the time as kids, we also first taught how to take a look at mechanical one. So let's see, and let me show you that you already know something of modulus and you're not aware that you're using it every day. So we'll create kind of a circle. We want to draw so basically a clock. Okay, so it will be divided into pieces that's known worldwide. And let's cut it then into even small pieces. Okay, now we go with 7. Okay, this is not really equidistant, but okay. We'll get to the point. And then let's say we want to tell it's like 3 o'clock. Usually people know that this marks 3 o'clock, right? But this can also be 3 a.m. and it can also be 3 p.m. So what do we do? Like, we know that like one day equals 24 hours. But what we know is like we don't have 24 marks on a clock, right? So when we say it's 1500, that actually means it's 3 p.m. So how do we do that? We do that using modulus, actually. So we want to divide 15, right? We want to divide it with 12. And in the world of whole numbers, that would be 1 with residue of 3. That residue we take as a modulus. So that's like you can tell that 15 is equal to 12 plus 3, and that would be perfectly fine. And you can add up numbers like that, and always, like, if you do the modulus, it will be always this result. So we can say 15 modulus 12 is 3. So this one says basically the same as the upper one. And you can tell, like, yeah, it's 3 p.m. Yeah, it's like 15 hours. That means it's 3 p.m. So that's how you can tell that you already knew modulus before showing you this. So we can also tell that that you know that you have seen modulus on a daily basis, right? So yeah, like let's make another example. So why is modulus important? Because if we would take, for example, if we would add 12 more to this, like 15 plus 12, it will go to 27. And if we would do 27 modulus 12, it will also be 3, because we have 2 times 12 into 27, and that would definitely yield the same result. So doesn't matter how much you add up 12, because that is the modulus. So that is the base. It will always yield the same result. So you can say like 5 modulus 3, it would be 2. 5, so we would say like 8 modulus 3, that would be also 2. Why is that? Because 8 is 3 plus 3 plus 2. So you see, like, doesn't matter how many times you repeat this, the base of the modulus, it will always yield to the same result. So it means that if you get the result of modulus and you say it's 2, and you have something like of let me try again. So if you have like modulus 3, so something modulus 3 equals 2, you don't know like how many times 3 repeated in itself. Like this can be also 2, but this can be also 5, and this can be also 8, and so on and so forth. Doesn't matter how many times we add 3, the modulus will always be the same, this kind of residue we have from the circle. So we can tell that this one is also congruent to 13. Sorry, so it's also congruent to 13. And this is also congruent to 14. And yeah, you can tell that from 2, yeah, it can be 2 a.m., but it also can be 14 hours. So, in a matter of fact, we all do modulus on a daily basis. So yeah, one thing is that we can also do modulus with negative numbers as well. In fact, modulus can always and only be a positive number. It can never be a negative number. So let's say this, so I don't know if you can see, but yeah, I suppose you can. Like, if we have, yeah, so let me write something. So if we draw a line, and then we can say, okay, this is 0, this is 1, this is 2, this is 3. Okay, well, we're again talking about whole numbers. But if we dwell into negative numbers, we can say it's -1, -2, -3. So how do we calculate modulus in this case? In this case, what we do is we're adding up, we're adding up this part until we reach the positive number. So, for example, in this example of a clock, if we would say, okay, if we would say what is -3 on this chart, okay, so we had to do like -3 modulus 12. So what would that yield? So we can go like in the opposite direction from our 0, to say so, and we can count like 1, 2, 3, and it will be 9. But how so? You can tell it this way. So you can say like -3 plus 12. Yeah, in the end, it equals 9. So yeah, modulus can never be negative. So this results we had, they can never be negative numbers, but we can use negative numbers to in modulus and make a good result, a positive one. Okay, so let's take a look at some more practical example and cryptography. So guys, let me know if you can see the alphabet here. Like, do you see complete alphabet, or do you see a part of it?
I can see a complete alphabet.
Okay. Yeah, because I'm seeing a part of it due to Zoom. But yeah, so where is the application of modulus? So in cryptography, we have shift cipher method. So with this, this is one of the oldest methods in cryptography. So we're actually assigning other numbers. So I don't know if you can see. Yeah, you should see that every letter of the alphabet has some assigned number. And then yeah, we do assign those numbers because we want to, let me see, check. So because we want to mix those and have something that is not a plain open message. So that let's say a general in a battle can have a different kind of message, but still be able to read it because they know the key. All right. So let's see. So I have prepared something. So since we have 26 numbers of the alphabet, so we can say we do modulus by 26. All right, and yeah, since you can see the alphabet, all right. Okay, so we can do Caesars. We can do so we can do Caesar cipher. So Caesar cipher has a key of 3. What does that mean? That means that we're simply shifting from A, we're shifting to D, and from D, we're shifting to G. And then you have something that's encrypted message, and it's completely scrambled. You cannot read it unless you know the method that is used and the key. And you can send a plain message, but maybe someone can intercept it, some kind of Eve, because there's always Alice and Bob in cryptography, and someone wants to try to read it in a plain text. So you can say like, okay, let me see. Okay, let's move it this way so everyone can see. Okay. So you can say like Alice send some kind of message to Bob. It's usually like that, but some kind of Eve, she wants to intercept that. She wants to know what Alice sent to Bob. So, but Eve does not know about shift cipher method and does not know about the key. So Eve will have bad time trying to intercept the message. So we have here a plain message. Yeah, we'll write something about ZKs, why not? So we can say ZK is awesome. Do we all agree on this? And then we'll take a look at the table and the numbers that fall under our letters. So we take a look at Z, and we can say its number is 25. We can take a look at K here, and we can tell it's 10. So we can take a look at I and say, okay, the number is 8. For S, we have 18. For A, of course, we have 0 because that's how it begins. For W, it's 22. For E, it's 4. For S, it's again 18. For O, we have 14. For M, we have 12. And for E, we have 4. So this is a plain message. Everyone can read this. So we turn this into numbers. So what are we going to do with Caesar cipher? So with every of these numbers, we're adding 3 to all of those. So we'll end up with something like this. 28, 13, 11, 21, again, this is 3, 25, 7, 21, 17, 15, and then 7. Okay. So if we try to go from the last one to the first one, even though that is not the rule, we'll end up if it's with something that's completely unreadable. So we'll end up with, so here is, here is age. For 15, we have P. For 17, we have R. For 21, it's V. For 7, it's H. 25, of course, it's Z. For 3, it's D. 21, V again. L for 11. For 13, we have N. And for 28, okay, when we take a look at our table, we don't have 28. Right, so we have to do the modulus. And with that, so if we take a look, it's 25 in the end, so it's Z. So we have to do some sort of a shift 3 times. And then, yeah, so okay, sorry. So we have to do 28 modulus 26 to see what it yields to. So like what kind of letter we're going to have out of this alphabet. So you can imagine it can go, so we could have like bigger keys like 20, and then most of the alphabet will have those modulus, but they will not have, you will not have like 40, but you'll have 40 modulus 26. So what this yields to, so yeah, like when we divide 28 with 26, we'll have 1, and then the residue of that is 2. So we know that that's how we calculate modulus now. So we take a look with 2. So we take a look at our table and say it's C. So this is our sort of encrypted message that Eve cannot read. So you see it says like CN, LB, DZH, BRPH. Does not say that ZK is awesome, but in a way it does say, because if the other party, if Bob knows that we're using Caesar's cipher method, so the shifting with the key of 3, he can definitely use the same thing and try to reverse it, and it will have the message that still ZK is awesome. So I think we can take some other methods too, like DeFi halving keys exchange, but I think we might do this in other lessons too. So far so great, guys. Do you have any kind of questions for me?
Actually, I think it's very clear and simple for me to understand it. Thank you, Milica. And I have no other questions, and I'm really looking forward to the next lesson. Thank you.
Yes. So for the next lesson, we're going into polynomials, and that will be then the third lesson of our Basic Maths Behind ZKs course, and then we'll have the fourth one. So yeah, like guys, if you have anything else to ask and it does not come to your mind right away, please write me on Telegram, Twitter, wherever you find suitable. And yeah, till the next lesson.
Sure. And if people have some questions, they can leave the comment on YouTube or in the WeChat group, and we can forward the message or forward the question to you. And every people feel free to ask anything you want about ZKs.
Yeah, sure. Like my Twitter DMs are open, so the privacy setting is open for everyone to send a message. So yeah.
Yes. And I think your lesson is clear enough and they don't have some questions. So let's wrap up the session and have a good day or have a good night.
Yeah, depending on the time zone you were in.
Yeah. Cool.
Right. Thank you all, and see you in the next lesson.
Yeah, see you in the next lesson. Goodbye.
Bye. Thank you.